Hello everyone. So today we are going to solve the problem number 329, longest increasing path in a matrix. So what the question states here. So we are given a m into n matrix. See here, we are given a m into n matrix. So this is 3 into 3 matrix, right? So just give me a second. Yeah. We are given a m into this one n integer matrix. What we need to do here, we need to return the length of the longest strictly increasing path. Length of the longest strictly increasing path. See, they have showed here 1 to 2, 2 to 6, so 6 to 9. The number longest, this is increasing, right? 1 2 is greater than 1, 6 is greater than 2, and 9 is greater than 6. So we have to return the length, not the this one, basically numbers. We have to this one return the length actually. In this case, it is 4, right? So we need to return 4. So that's what they have said. So given an m into n integer matrix, we have to return the length of the longest strictly increasing path. We may move up. So we may move up, down, left, or right. So no diagonals are allowed. So we cannot move in this direction or in this direction, right? So we have to find the longest path length where each step goes to a strictly larger number, where each step goes to a strictly larger number. All we have to do is we have to find the longest path, right? So this is very simple, man. See, in the first this one example, they've shown here 1269. So this is the longest path. So if we consider this one, 4 8, so it will stop at 8 itself. So if we consider this one, 1 is equivalent to 1, so it has to be greater than the next number. So sorry, the next number has to be greater than the current number actually. So it doesn't happen, this one as well. Then we will go to 1, 2 is greater than 1, then 6 is greater than 2, 9 is greater. So this one will be actually 4. So this is fine. Next, we cannot move here because we have 9, right? So if we start from here as well, it is 8, but next number is 1. So yeah, uh, you can move however, basically it doesn't matter, up, down, left, or right. You can just check from any cell actually. This will be the actually longest, this one, longest path, right? So we have to return the length. In this case, it is 4. So we have returned 4. So same goes with the second one as well. For the second one, we'll be starting from the top left cell actually, the first one, 0, 0. So this one will be 3, 4, 5, 6. So this is going to be the longest path. So we will be returning its length, nothing but 4. Here, here also it is 4 actually. 1, 2, 3, 4, 5, 6, right? So 3, 4, 5, 6, 4. This one length is 4. The longest increasing path is 3, 4, 5, 6. Moving diagonally is not allowed. So yeah, so overall it is 4. Yep, this is fine, man. Yeah. Now for the third one, we have only one element, so the output will be quite obviously 1. Yep, so this is fine, I believe. So they have given us wonderful examples just for the sake of understanding. Now let's do one thing. Before hopping into the approach, let me tell you one thing. We will be making use of the 2D this one DP, dynamic programming basically. So we will be going with the 2D memoization, 2D memoization, basically 2D memoization along with the DFS to solve this particular problem. Yeah, just remember we'll be making use of the 2D DP along with the DFS to solve this problem. Yep, this is fine, I believe. Now let's discuss the approach step by step, man. Yeah, let's consider the same example. This example, I'll just delete this one. Yeah, let me come here. So let's consider same, the first example here, this one. Right. So we will pick the cell with a value 1. We'll pick the cell with a value 1 initially. So this will be, let me write this one over here. 0, 0, 0, 1, 0, 2 cell numbers actually. Yeah. So this will be 1, 0, 1, 1, 1, 2, 1, this one 2, 0, 2, 1, and 2, 2. So this is fine. So this is 3 into 3. Great, right? So this is fine. 3 into 3 matrix. Now we'll start with the lowest value. Nothing but we'll start with a value 1 actually. We'll start with this one, this one. It will start the DFS actually. This is 2, 1, sorry, not this one basically. Yeah, we'll start with a value 1, nothing but the 2, 1. We'll start the DFS because we will check whether the current number is greater than the next number or not, right? So we'll start the DFS 2, 1. So this is unknown. So this is unknown. We'll explore the neighbors actually. We'll explore the neighbors. From 1, we can go to 2 at 2, 0 because 2 is greater than 1. So we will move this side, this one, right? So this is fine. accordingly with the condition or the criteria. So we DFS into 2 comma 0. So it will be from 2 comma 1 to 2 comma 0, right? So this is fine. The next one is from 2 we can go to 6. From 2 we can go to 6 because 6 is greater than 2. Because 6 is greater than 2. So from 2 comma 0 we will move to 1 comma 0. Yeah, this is fine. Next, we will DFS into 1 comma 0. We have already done that one. Next, we can move up actually. We will move from 1 comma 0 to 0 comma 0, 0 comma 0 because 9 is greater than 6 here. We will DFS into 0 comma 0 and 9 has no longer neighbors. We will check, we can check only right. We cannot move diagonal. Left, we don't have any cell left. Up, we don't have any cell. We have only neighbor that is right actually. The right cell is the value is actually equal. Basically the right cell consists of the value 9 which is equivalent to the current cell, right? So 9 is equivalent to 9, so we will stop here. We will stop here. So we have moved from 2 comma 1 2 comma 0 to 1 comma 0 to 0 comma 0. So what is the length actually? 4 here, right? So we will backtrack basically. We will go with the DP of 1 0. We'll start with the DP of 1 0 actually from this one 6 actually. We'll try again 6. So this one 6 also fails, right? So this one 6 also fails. We'll start from DP of 1 0 is equal to 1 plus DP of 0 0 nothing but 2. DP of 2 0 1. So everything fails here, right? Everything fails here, right? So this is fine. So what we will do, the length here that we got here is 4 actually. Whatever the length here from 1 we have started, this one, the length we got here is 4. One thing what we will do here, we will be going with the cache, meaning we will memorize DP, this one, cache DP actually, that prevents recomputing the same cells, right? So once the cell is computed, we'll be marking that one as visited, right? So we'll repeat for all the cells and take the maximum DP value that is equivalent to the 4 that we got here, right? So the value that we got here is 4. This one, basically this will be 1269 actually. Yeah. So this one 12 value I'm mentioning instead of the cell number. Yeah. So this is 1269. Yeah. The output that we got here is 4, which is equivalent to the output that they have mentioned for the example one within the question. So our approach works absolutely correct. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to pick of m into n. The time complexity would lead to pick of m into n. Why it is m into n here? Each cell is computed exactly once and each DFS explores up to 4 neighbors, whether it may be up, down, left or right. So memoization prevents repeated full recomputations. We are going with the memoization as I've said in the, as I had stressed in the this one, what do we call approach. Yeah. So what will be the space complexity? Space complexity would lead to big of m into n as well. So the time complexity would lead to big of m into n for the DP array. This one, each cell is computed once and each DFS explores up to 4 neighbors. We know this one. The space complexity is also m into n because we will be making use of the DP array and the recursion stack. In the worst case, recursion depth can go yeah, recursion depth can take up to m into n and this one pathological strictly increasing snake. Yeah, so this one, the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n and big of m into n respectively, right? So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. First thing, so we have to perform the DFS as well, right? Along with making use of the DP, we have to go with the DFS as well. First thing, let's go with the base condition, or let's do one thing. Let's handle the null or empty input first. No cells, then the path length has to be 0, right? So I can just write it in this way. If matrix equals null or length of the matrix, so I'll just go, let me copy this one, matrix dot length, this one, if it is equal to 0, or for the column also we have to consider. So I'll just go with a matrix of 0 dot length here. So if it is equal to 0, then we have to return 0. Then we have to return 0. Next, let's go with the this one, number of rows as well as the number of columns. So let me initialize m2 matrix dot length, and also for the columns, let me go with n equals matrix of 0 dot length. So this is fine. Now, dp of ij will store the length of the longest increasing path starting at the I comma j. So let's initialize the dp first in simple terms, right? So this one will be int dp equals new int of rows and columns, nothing but here m into n of sizes m into n respectively, m and n respectively. Now, result stores global maximum path that this one global maximum path length that is found, right? So we have to make use of the result variable. Let's initialize the result to 0. Next, what shall we do? So we have to iterate over every cell and compute its length path via DFS, right? So let me write here for loops, and then we can just write the helper method. Then we can make use of it within the main method, longest increasing path. So I'll just go with for I less than m. So this will be I plus plus. Next, for j equals 0, j less than n, columns j plus plus. So within the for loop, what we have to do, we have to compute the dp of ij that is cached, right? If already computed, and we have to update the result as well. Yep. So I'll just go with the result here. I'll just go with math.max of result, comma. So we will be making use of the DFS here, DFS over here, right? So me do one thing. We have to make use of the DFS here. So we haven't written the DFS helper method. So we have to perform DFS here, but we haven't written the DFS helper method over here. Let's write the DFS helper method, and then let's make use of the DFS helper method within the main function longest increasing. Yeah. So now let's write the helper method DFS, this one that returns the longest increasing path that is starting at I comma j. So I'll just go with private int DFS. So this is fine. Int matrix. So this is fine. Int dp. So this one will be int I, int j. So this one will be int m and int n as well. Yeah. So this is fine. Now, if the dp is already computed for the particular cell, then we have to return the cached value, right? So we are going with a memoization. Just remember this. So I'll just go with if dp of I and j, if dp of I and j, if it is not equal to 0, then we have to return dp of I and j respectively. Yeah. So at the minimum, the path that starts at the particular point has length 1 initially, the cell itself, right? So let me assign dp of ij initially to 1. Yeah, this is fine. The length actually, initial length. So we can move in the 4 possible directions they have given in the question, right? They have strictly given in the question. One is up, down, left, and right. We cannot move diagonally. So let me consider here directions. I'll just give dirs here. So this one will be, mm, let me go with, mm, so first we are going with up, down, left, and right. So I'll just go with minus 1 comma 0. This one will be 1 comma 0. This is fine. Next, let me go with 0 comma 1. And finally, let's go with uh, this one. Let me go with 0 comma minus 1 here. Finally, we can just go with 0 comma 1. Up, down, left, and right respectively. Yep. So this is fine, man. Now let's do one thing. Let's go with the current cell value. Current cell value in the sense, let me assign the value to matrix of I and j respectively. Right. So let's explore all the 4 directions, man. So let me go with the iteration part or the for loop. So this one will be for int d of directions. So this is fine. So within the for loop, let's do one thing. Let's go with a neighbor row or let's go with a neighbor column as well. So int mm, ni equals I plus d of 0. This is fine. Um, int nj equals j plus d of 1. So this is fine. Neighbor row and neighbor column. Now let's check the bounds and strictly increasing condition. So let me go with the if condition here. Ni greater than 0, and ni less than this one m actually, and also let me go with let's include nj if it is greater than or equal to 0. Sorry, the equals come here, man. Nj greater than or equal to 0, and also this is actually the bound check, right? So we are going with a bound check actually, boundary check. So this is fine. And what if nj less than n? It shouldn't be less than n, right? So also let me go with the matrix of ni and nj if it is greater than value, right? Then what we should do, so let me go with dp of ij. So then we have to recursively calculate the neighbor's longest path and update the dp of ij. So that's what we will be doing here. So I'll just go with math.max. So this one will be dp of ij. This is fine. 1 plus dfs of, let me go with the matrix. Let me pass dpni as well as nj, this one m comma n. So this is fine, man. Yeah. So let me come out of this one entirely. Now let's do one thing. Let's return the calculated or memoized value for the particular cell, right? So I can just write it in this way. Return dp of I as well as the j. Return dp of I as well as the j. Let me format the code once. And now let me come to the main function. Here, let's do one thing. Let me go with a result. Along with the result, let me go with the DFS of matrix dpij m comma n, right? So this is fine. So let me come out of this one entirely. Finally, let's return the maximum length that's found actually, that we have found. So this one will be, let's return the result actually. So this is fine. Yeah. Let me format the code and let me hit the run button. So I hope this works for all the test cases. Let's see. Oh, this one has to be actually comma. This is fine. That is the only mistake, I believe. Line number 17. So in dp, so this is fine. Let me run this one again. Wrong answer. We are getting output 3 instead of the 4. So there might be problem with the DFS, within the DFS actually. Let's see. Just give me a second here. So I have made a mistake in the boundary check here. Yeah, I knew that I did a mistake in the DFS function actually. So this one boundary check, this has to be ni greater than or equal to 0, or else we'll be getting the this one wrong output. We'll be getting 3, right? So it will not check the top cell, I believe. This one, if we don't give ni greater than or equal to 0. Yep. So let me do one thing. Let me run the code again now. This has to work. Let's see. Yeah, yeah. The sample test cases are getting passed. So let me hit the submit button quickly. I hope this works for all the test cases, man. Let's see. So yeah, here you can clearly see all the test cases are getting passed. So whatever the code that we have written works absolutely correct for all the test cases. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.